Welcome. Let's talk one last thing about sponges, and then I'll pretty much leave them alone. I think there's one more of these that mentions them. So, I said that the earliest origins of sponges are controversial, and they are. Um, Here is the paper about one of those, and if this is correct, it could be the oldest sponge fossils, sponge body fossils. And if it's incorrect, it's something vaguely like a sponge that's not quite a sponge. And since we're this far back in time, probably we shouldn't be looking for things to be exactly like a sponge. But on the way is something. So this was dated by rhenium osmium measurement dating to about 892 million years ago. The MA is million, and the A is like anno, so it's year. And you'll see GA, which means billion years. Yeah, KA would be thousand years, but you don't see that very much. So yeah, there you go. It's different way of saying MYA, million years ago, and it's better because it's not like yeah, I don't know. It's just a little shorter. Okay, so let's go. Here is the formation. Here is the band. Here are the reefs. This is actually a reef forming something or other. But look at the dates. So this one was dated pretty soundly. Rhenium osmium dating is pretty good. There are other dates around here, though. So there's detritus in making up this one that is about a little over a billion years old, we think, but with bigger error bars. And so that means the age of this rock is less than the detritus, like broken down bits of rock that are in there, but it may be pretty close. Yeah. Then you got a dating of 775 million years done a while ago. Maybe not quite as accurate, but also you got a range in here. So you know it's pretty old. All of these dates, at least the first two, would be in the Tonian. The Tonian is the bottom of the Neo-Proterozoic, which is like the big chunk Precambrian, the era that comes before the Cambrian starts the Paleozoic era. And so the newest of those is going to be the Ediacaran. The middle one is called the Cryogenian, which is when the Earth froze over. And the bottom one, which is about as big as the other two put together, is the Tonian, Tonian. And it makes up about half of the Neo-Proterozoic era. They only divide this entire era into three periods, which I guess is like the Mesozoic, but they are much longer periods than the Mesozoic, and that's because there are relatively few fossils, they're relatively hard to find, and most of the things that were alive were single-celled, and those usually don't fossilize, no matter how much you want them to. All right, so have a look at this. They call them vermiform, like worm-shaped structures. And so here we go. We've got these little wiggly worm-shaped channels. And in some of the other figures in there, they zoom in on the channels. You can see they are sort of crystallized calcite that is filled in these little chambers. But the chambers are all about the same width. And that would be pretty normal for a living thing and kind of weird for a mineral. They are comparing it to these sponges. So this particular kind of sponges has a network of tubes that runs through it, and these are made of spongin. And they're saying, you know what, it could be something like this. These are the tubes that are left, and they're just running through either the body of the animal that was fossilized, essentially replaced by carbonate minerals, or that they were kind of a stony growth with water channels, and there was sort of feeding along those water channels and active pumping like you would get in a sponge. All right, let's go deeper because this is controversial. Here's one of those reefs. So you can see it has this crust on it. And these are marine carbonates, so calcium carbonate crystals going all around the edge. And so that's fine. That's something that formed and was deposited probably after this was alive. Here's the dirt that it's on, or the rock that it's on. And here is that, vermiform structure. So it looks like it was made by something alive. Does that make it a sponge? I don't know. Yeah, maybe not, but we know sponges should be very primitive, extremely primitive, or sponge like organisms, because we know that conoflagellates, which are the step before animals, are like a single celled sponge, occasionally two or three of them together. And we know that porifera, which are like the second or third step of animals, are sponge like, and they have essentially chambers full of conoflagellates. And so the idea is it's called phylogenetic bracketing. If you've got things running down different branches that come from a common starting point, the safest assumption is that the starting point probably looked a lot like the common features of those branches. Not guaranteed. This is a world where convergent evolution happens, where things grow to look more like each other because they're trying to do the same job usually. But it's the easiest assumption. It's the most logical, reliable assumption. So, what's the context on these things? Well, you've got this sort of slope down here, and they say, yeah, we notice that there are bits of these blocks. It looks like there may be stromatolites. And you'll remember those. We're going to cover those in a little more detail later. But those are going to be layered structures that are built mainly by bacteria. And they're going to build up little layers of rock and do photosynthesis. So these things live in shallow water, often in the intertidal zone is where you find modern stromatolites. And so it says, yeah, these stromatolites are breaking off in chunks and they're landing down here, and the rock is forming around them from the sediment that's washing down. But it says that here are the actual little organisms that they're talking about, and so they are growing around here, and there are also some of these growing up here that they're making a little bit of a reef that's even higher. And so they're part of the reef. They're these little red lines, and they are also part of the stromatolites. They're making little deposits in the stromatolites. Right there, you could say, is something growing on a stromatolite? Maybe. It could happen. It does happen. Is something part of the stromatolite? Well, it doesn't look like the rest of the stromatolites, so it doesn't appear to be a normal part of it. And it is found on the stromatolite and next to the stromatolite and in little shelters beside it, and as part of other different kinds of stromatolites. So it's associated with them, or rather it's living in the same places which are already dominated by stromatolites. I think that's a safe assumption. Our mascot for today, look up there, is the oldest, I think pretty confident sponge body fossil that's out there, just so you can compare this mayhem to something that seems a little more easy to digest, as a sponge relative. So that paper came out. It was pretty cool. Yeah, I looked at it and thought, wow, they've got something. I don't know if it's a sponge, but they think it's a sponge, and they know more about this than I do, so maybe they're right. And then right after it, there's a bioarchive paper, and then it takes about a year and a half to turn into a real paper, and they do tons more work on the in-between stage. So it may have gone through multiple rounds of editing, review, revision, like reviewers saying, add this stuff, and they added it. Anyway, here is a little section from the abstract, I believe, either that or the intro of that paper. And so the type of sponges that they said this could be, the vermiform, they were saying, it looks like a keratose sponge. And those are the ones that include bath sponges. These are sponges with no spicules, but with long spongin tubes that run through them, which are for conducting water. Okay. Despite numerous studies, verification of these fossil keratose sponges is lacking, meaning that we think they ought to be there. Genetic studies indicate that these sponges should exist pretty early on. We have some of these sponges that are actually pretty stony in character. They're pretty solid with these little spongin tubes running through them. But saying, you know what, some of them may be sponges, but there are other possible explanations, like Myofaunal activity. What if you have some sort of creature that is tunneling in some kind of substrate, that builds up? It could be a little microbial mat of all things. Yeah, this is before the Ediacaran, so there are definitely microbial mats in places. Yeah, is this burrowing in a microbial mat? I don't know. Is it layered microbial accretion? Basically like a stromatolite, but a different grouping of bacteria that makes a different looking stromatolite. Possible. It's not really built like one, but it does grow on them and in them and right next to them. So you got to at least consider that, I think. And it says there are some stromatolites that are kind of spongy or sponge-like, and so maybe it's one of those, which maybe it is. We're dealing with almost 1 billion years ago. Things were different, and make assumptions at your own peril. Okay, sedimentary, colloidal, and clotted micrites. So, just like things that have been cemented together by microbial action. It's possible. I don't know why there would be channels there, but we have other fossils from the Ediacaran that appear to be just gas bubble escape channels made by possibly methane-producing bacteria. Are they fluid escape channels so vuggy means like you have inclusions, things that are ugly. It's a cool word to break out in Scrabble. VUG, vug. Yeah, it's an imperfection in a gem, for example. So is this just where this rock was squeezed and fluid escaped and made little tunnels from it? And it was just, these are just little inclusions of rock that are in there. I don't know. Are these little channels the molds of spicules, like the actual bones, from a real sponge that have just been either clumped together, or are these, was this the sponge body, but it was not a keratose sponge with no spicules, it was a spiculate sponge with spicules. Yeah, I mean, some of those are more reasonable than others, but I'm with them. So they're saying, hey, it's important that we know because there's big implications in terms of the evolution of sponges, because they're thought to be one of the earliest branches. So they'll go on and explain. So here's what a keratose sponge looks like after you've demineralized it. Here is a sort of a thick minerally keratose sponge while it's either still alive or very recently dead. Here is a couple completely demineralized keratose sponges, and you can see what they have are networks of little straight tubes in the modern ones, not these sort of wiggly, wobbly tubes like that. And I'm not sure, these look like little chambers, these spots that come up lighter and seem to be the ends of little pathways. But you'd want to see that in 3 dimensions. It would be good to have a 3-dimensional map of these. See if they all connect up like they presumably would in a sponge, although we're assuming this thing has already figured out how to be like a modern sponge, and there have to be intermediate steps, and the intermediate steps may look a little messy. Yeah, gotta say. So then they say, hey, wait a minute, let's look at a bunch of other sponges that exist. So these are things called sponge mummies, where I think the sponge got filled in and dried out like a lake evaporated or something like that. And then you got sediment squeezing into some of the channels that used to be occupied by the sponge. And so you'll have little channels, and these are a little straighter, but these are sort of marking where the water channels were in the sponge. So could it be something like that? Sure, it could, yeah. And they're showing here are some definite sponge fossils. And so here's what we see. This is the... when you have a sponge that has spicules, like the little spiky bones, and the spicules dissolve in the fossilization process, you're left with little holes that have little shapes like this. And the holes will sometimes appear to connect to each other. And so, yeah, could this be what's happening there? It was actually a sponge with spicules that, they got dissolved during fossilization, and we're left with that. So I guess they're not completely opposed to the idea that it's a sponge. They're just saying, it's tough. And I agree, looking at the original paper, it was tough. But, So here's what we know right now. So people have looked at sponges, they've made nice phylogenetic trees, and you can calibrate these based on where the tree joins up and how many mutations you'd have to make to get to the branches, and then how many mutations living things make in the process of replicating. And so, based on that, you can come to a lot of interesting conclusions. So, the sponges that we know, heteroscleromorph sponges, should appear in the Cambrian, but they look like demosponges, so you may not be able to detect those. And then it's saying these are the rest of the demosponges over here. They're all branching from demospongii. And we think those would have radiated out in the Ediacaran. However, there isn't great evidence for that. And then they're saying keratosponges lost their spicules, and so all their children, including Spongia, the bath sponge, I think, basically are not going to have spicules anymore. And they're saying that on this branch, everything in group number 3 also lost its spicules. Things in group number 4 mostly have their spicules, but there are a few that have lost their spicules. So they're saying this is probably evidence of independent loss of spicules, because it would be weird if spicules were lost back here and then reinvented in several of the clades up here. That would be very, very strange indeed. They're saying that, all right, so if that's the case, then one, we're way too early for there to be a keratose sponge, because you have to have demosponges first, and we think those probably don't exist until the late Cryogenian, and that's based on detection of spongin-like compounds, as I understand, or this would be the origin of the demosponges. And these would all have spicules at this point, is what they're saying. And like you're probably asking, I hope you're asking, well, what about Archaeocyatha? Yeah, they're just saying that's a parallel group to the sponges, I believe. And they are choosing not to put them onto this branch, because those have their heyday in the Cambrian, but they lack spicules completely. And so they may be an early version that's lacking spicules, something like that, an early keratose sponge that looks nothing like any modern keratose sponge. Or they may be something else, another side group over here. But anyway, they think that all these things radiated in the late Cryogenian, and if they did, then the Tonian, which is when the fossils in question are from, is much earlier than that. It's like the 280 million years before the start of the Cryogenian, so a long time where a lot could happen, and where we have very few fossils. So they're thinking metazoa, like animals in general, probably are Tonian, and then porifera split off from all the other types of animals, sometime either very late Tonian or in the Cryogenian. Yeah, and so that's another way of looking at this and putting a little context on it. So there you go. That's a little bit about sponge fossils, some of the controversy around sponge fossils. So how old are these? Tonian, when is that? Look it up. Describe these fossils. So it's like calcite in a sort of accumulated, it almost looks like detritus. It's like cemented together. It could be a microbialite, or could be some kind of infill, or could be something that a sponge has built. Yeah, a very sort of light and fluffy version of a solid rock. But they are carbonate, so made of calcium carbonate. What are keratose sponges? They're sponges that lack spicules and either have a stony body or a sort of a rubbery body, but they're going to have little tubes made of spongin running through them, and that's going to be one of their defining features. And what are the other interpretations that fit this data? Well, the authors of the second paper told you all about those. Two very interesting papers talking about the same thing. And ultimately, talk will only get us so far. I got to go out and find some more fossils, section them, and hope you get lucky. So there we go. Let's hope we all do.